everyone, I'm Tamumun, metric number DN210117. I'm my friend Afiq, Dimas and Fazana would like to do a presentation about the project entitled of Analysis and Simulation of Three-Phase Star Connection Circuit. This is the circuit that we are chosen for our project. It is a 4-wire three-phase star connection circuit. It is connected to the line voltage of 381 volts with 50 Hz supply. Each phase of load consists of 50 ohms resistor and also 63.6 microfarad capacitor. The lines red, neutral, blues and yellow are connected at a point N which is called star point. There are a lot of applications for this circuit. Firstly, for main supply transformer, it provides a 4-wire three-phase connection to the grid with a choice of 2 voltage and 3 single-phase connection for appliance and small installation. Secondly, for heaters, it allows the use of single-phase heating elements of the same current rating to be connected to 3-phase power for higher heating capacity. Lastly, for motors, it is used to start a larger motors and then switch to delta connection for normal use in order to reduce the start in rush current.
Assalamualaikum and hi, my name is Muhammad Khairul Pramudia and my matrix number is DN210015 and I would like to explain about calculation for circuit analysis 3-phase star connection. For 3-phase star connection, the theoretical formula involves total reactive power, phase voltage, line voltage, phase current, line current, power factor, complex power, apparent power, total apparent power, active power, total active power and reactive power. Next, calculation by using theoretical formula for phase voltage is VL divided square root 3 and the answer is 220 volt and the line voltage is 381 volt based on the value on circuit. To find phase current, the formula is YPH equal to 1 over R minus JWXC and the answer is 0.02 minus J 0.02 ohm, followed by the next formula which is IPH equal to VPH times YPH and the answer is 6.22 ampere. For formula line current is IL equal IPH which is the answer is 6.22 ampere and the power factor formula is PF equal to cos theta and the answer is 0.707 leading because the load admittance is negative. Formula complex power is S equal to VPH times IPH which is conjugate of phase current with the answer is 1368.4 volt ampere and the total apparent power formula is ST equal 3 times S with the answer is 4.105 kilovolt ampere. For active power, the formula is P equal to VPH times IPH cos theta with the answer is 167.6 watt and for total active power is PT equal to 3 times VPH times IPH cos theta with the answer is 2.903 kilowatt. For reactive, the formula is Q equal to VPH times IPH sin theta with the answer is negative 967.6 watt and last formula for total reactive power is QT equal to 3 times VPH times IPH sin theta with the answer is 2.903 kilowatt. And that's all for me. Thank you.
Next, I would like to show a recorded video about the simulation of this circuit. This is the simulation that I done in the MATLAB software. To draw the circuit, we need to go to the library brush and then select the component that we want to use. Just drag it out into the model window. If we don't want, we just delete it. Alright, so for this simulation, we need power U component in order to run the simulation. Otherwise, it will give error. We need to use the components such as 3-phase proportional voltage source, 3-phase voltage current measurement, 3 series RLC branch and also ground. To get the result, we need to use the display component. To get the current, we need to use the components of current measurement and RMS, while to get the voltage, we need to use the components of voltage measurement and RMS. To get the apparent power, we need to use the product component that is connected to the current and voltage. To get the active and reactive power, we need to use the components of 3-phase power instantaneous. Lastly, to get the power factor, we need to use the component such as 2 product, 1 sum, 1 square and 1 divide. For information, only the peak-to-peak voltage can be used in this simulation, so we need to use 762 volt as the line voltage. We need to use 0.1 as the stop line to get the accurate result. After completing the circuit, we need to click the run button to run the simulation and wait for a while to get the result. Alright, so this is the result. The power factor is 0.7068. The current is 6.217 ampere. The apparent power is 2735 volt ampere. The voltage is 439.9 volt. The active power is 5801 watt. And also the reactive power is negative 5806 watt. Alright, that's all for me. Thank you.
Hi and Assalamualaikum. My name is Fazana Nazira binti Ramli. My metric number is DN210031. I will continue with result and discussion. The result of calculation and simulation of three-phase star connection circuit analysis are shown in the table 1. In the calculation, any types of voltage, for example, phase voltage, is shown in the value of peak voltage or VPH. However, in the simulation, the phase voltage is shown in the value of peak-to-peak voltage or VPH minus PH. This is because only peak-to-peak voltage can be used in the component of MATLAB software for doing the simulation. Therefore, the value of peak voltage can be obtained by using the formula of VPH equal VPH minus VH, or value of peak-to-peak voltage divided by 2. From the table 1, in the simulation, the value of line voltage, phase current, line current, power factor, and total reactive power are same with the calculation and simulation. On the contrary, the other value, for example, apparent power and total active power in the simulation, have a little bit different with calculation. This is because the simulation may not always produce accurate result due to it works on logical manipulation. For the information, only the value of apparent power or S, total active power or PT, and total reactive power can be shown for this simulation in the MATLAB. That's all for me. Thank you.
Assalamualaikum. My name is Afif Abqori bin Muhammad Zain and my metric number is DN210010. I'm here to talk about conclusion, application and future recommendation. In conclusion, the fundamental law and element of power AC electric circuit is applied in the three-phase star connection circuit analysis and simulation. The three-phase star connection circuit can be analyzed through calculation by using the basic concept and fundamental principle of electrical power circuit analysis. Hence, each step of calculation for the circuit analysis can be simulated and demonstrated by using the MATLAB software successfully. For the future recommendation, in the aspect of induction motor winding, it is recommended that the circuit of the motor need to use the delta connection compared to star connection due to the delta connection has higher torque than star connection. Each motor winding of delta connection will get phase-to-phase voltage that make the voltage become high. Therefore, the torque become high because it is directly proportional to the voltage. Finally, the suggestion for three-phase power supply can be contributed by using the star connection. This is because the construction of star connection involves the combination of three single phase into one phase are more efficient compared to the delta connection. A three-phase power supply can transmit 3 times as much power as a single-phase power supply, while only need one additional wire, which is the 3 wire instead of 2.